Alright, this is Saxon Algebra 2, lesson number 114, and it's entitled Nonlinear Inequalities. We've been doing inequalities, systems of inequalities, and we've had systems of linear inequalities, meaning we have two lines that intersect somewhere, and then we had to decide what section to shade because of our inequalities. We had dotted lines if it was not equal to, solid lines if it was equal to. So we're familiar with all that. And we've been doing systems of nonlinear equations, meaning we might have a circle, we might have a parabola and a line that intersects, and we find the point where they intersect, or we might have a circle and a line or a hyperbola. And I gave you all of the forms of those equations so you could identify what it is you're supposed to be drawing from those equations. Now we're going to have nonlinear inequalities. So they're going to look very similar. This first one's going to be, well, I'm going to write them as an equation first. X squared plus y squared is equal to 9. And y is equal to x. So this could be our system of equations, and we would be looking for a point or points of intersection. The point on the circle and the point on the line that was the same. But we now have an inequality. So instead of x squared plus y squared equaling 9, x squared plus y squared is greater than 9. And instead of y only being equal to x, y is greater than or equal to x. So we're still going to start with the same circle and line. So the circle, remember, has a center at 0, 0. That's the center of the circle. And it's got a radius that's the square root of 9, which is 3. So I come out here 3, and come out here 3, and down 3, and up 3. And that's my circle. Y'all know I draw beautiful circles. There we go. So we know this is it because the radius of that, because the center is at 0, 0, and the radius is 3. So that's our circle. Now, in our inequality though, it's missing an equal to sign. It's missing that equal to sign. So we're going to have not a solid circle, but a dotted circle. Let me go around and put my dots on there. And then we're going, the second inequality is a line. That line is, that inequality is greater than or equal to, so my line is going to be solid. And whatever x is, y is. So, at 0, 0 is x. X is 0, so y is 0. X is 1, so y is 1. X is 2, so y is 2. X is 3, so y is 3. And so on. So it's going to look something like this line right here that I've drawn. Now if we were doing a system of equations, it would be this point and this point that we're looking for. But we are not. We're doing a system of inequalities. So we first need to know, we're going to start with the circle. Do the circles inside the circle, do the points inside the circle make the first inequality true, or the points outside the circle? I've said this before when we were doing, maybe not in here, but as best I can, I like to use 0.00 because that's the easiest one to calculate. So 0 squared plus 0 squared is 0. Is 0 greater than 9? The answer is no. Therefore, it is not the points inside the circle that make this inequality true. It's the points outside the circle. And now, y has to be greater than or equal to x. The points on the line are where y is equal to x. So the points where y is greater than x would be the points above the line. My 0, 0 doesn't work right there because it's on the line. But if I said this point here, this is 0, 1. If x is 0 and y is 1, that point makes this inequality true because 1 is greater than or equal to x. So the points that make this system true are the points that are outside the circle and above the line. So that's all of this right here. Outside the circle and above the line. Any point here. One point outside the circle and above the line would be right here, and it would be, because my radius of my circle is 3, it would be 0, 4. So if I put 0, 4, if I put 0 in for x and 4 in for y, I get 16. 16 is greater than 9, and 4 is greater than or equal to 0. And for your purposes, Saxon's going to draw these pictures for you. Saxon's going to draw the picture for you, and it's going to label the areas. For example, in this practice, this area was B, A, this area is B, this is C, and this is D. So you just have to answer which area is your solution. So the answer to this one would be A, because that area is above the line and outside the circle. Thank you very much.